Now, sampling error and how do we attempt to reduce it? Now, again, as we said that Monte Carlo simulation is a numerical technique. So whenever we are using numerical technique, we are trying to make an approximation uh, to arrive at a certain value which you can use for our subsequent purposes. So it is because of this reason that keeping a track of sampling error becomes important because we want to rely on a model which is accurate enough. And sampling error helps us understand what is the accuracy of the model or maybe what's the standard error of our estimate. Now, the standard error of estimate is given by the simple formula S upon square root of n, where S is the standard deviation of our final output variable and n is the number of simulation paths. So we can imagine that the accuracy of the Monte Carlo simulator is a function of two items, as we see here. It's a function of standard deviation of output variables, and it's a function of number of simulations we do as well. Now, naturally, we cannot have a control on the standard deviation of the output variables which we are simulating. However, we do have control on what can be the number of simulations n. So ideally, we would want n to be very, very high because n is in the denominator, right? So if you want to reduce the standard error, n needs to be sufficiently high so that our size of the denominator increases and this brings down the overall standard error of the estimate. So that's what we see here. However, one thing to be taken into consideration is what should be the correct value for n. Now, unfortunately, there is no one single answer to this because that will depend on what is the computing power or what is the technology infrastructure which one is working on. So as we keep on increasing the number of paths, that increases the amount of computation power which the model is going to demand. So this is where you need to decide on a balance between model accuracy and system efficiency. Because remember that in any bank or any other large setup, modeling is one thing, but there are many other functions which require the system bandwidth, which we call as the IT infrastructure. They also require to use it. So it should not happen that because we are running so many number of paths, that is, we have like imagine like n tending to infinity. If we are running so many number of paths, it makes then we end up consuming most of the computing power, and that might have detrimental impact on other mission critical activities as well, which is naturally unacceptable. So that way, it's important to estimate this value for n. So that is something which will come via trial and error. And once we freeze on that value, we can start using it for our, our simulation purposes.